AI is being built like infrastructure, and infrastructure always runs into constraints. In early December 2025, Reuters reported that the AI boom is driving a new global memory chip supply chain crisis, with companies fighting for dwindling supply and prices rising. Then, just days later, Micron's CEO said he expects memory markets to remain tight past 2026. And IDC-linked reporting has warned the crunch could persist until at least 2027, pushing up prices for phones and PCs. That's the real story. Because AI compute isn't the only scarce resource in AI. The bottleneck is what feeds compute. Memory. Not storage, memory. And the same suppliers feeding AI servers also feed phones and PCs. So when memory gets tight, the outcome is predictable. Higher prices, slower upgrades, or lower specs. If you want to understand what happens to consumer tech next, you don't start with the processor, you start with memory. Let's clean up the vocabulary. Storage is where your files live. Photos, apps, documents, video. Memory, RAM, is where your device works. It's the workspace. Here's the practical question. How many things can your device keep open before it starts reloading and stuttering? When you open an app, load a page, or edit a video, your processor stages the working set in RAM because RAM is fast enough for real-time interaction. That's why two devices can share the same processor and still feel completely different. If the CPU is the worker, RAM is the workbench. And modern software keeps raising the bar, browsers, 4K workflows, and AI features running in the background. So RAM isn't just a spec, it's a limiter. When people say memory, they usually mean RAM, but the industry is really dealing with a stack. PCs use standard system RAM, phones use low power RAM, and storage uses NAND. AI adds another category that matters a lot, high bandwidth memory, or HBM. HBM isn't more RAM. It's RAM designed to move data extremely fast, so expensive AI chips don't sit idle waiting for the next batch of data. Quick question, in AI training, why can bandwidth matter more than size? Because when the pipe is small, the chip waits. AI workloads don't just need compute, they need throughput. Think about it. What's the point of a fast engine if the fuel line can't keep up? That's memory in an AI system, a pipeline. Models read and write huge amounts of data repeatedly, over and over, while training and serving results. And as models scale, memory demand doesn't rise politely, it climbs aggressively. So the AI boom isn't only a GPU story, it's a memory story. GPUs are the engines, memory is the fuel system. If the fuel system is constrained, the engine becomes an expensive idle. Here's where this becomes more than supply and demand. This isn't only a shortage, it's allocation. Capacity is finite, so manufacturers choose what to prioritize. Quick question, if you're a supplier and AI buyers will pay more, where does your best output go? And allocation has geography. This supply chain is concentrated, only a handful of regions can expand it meaningfully, quickly. So when priorities shift upstream, the whole market feels it downstream. Think of it as a zero-sum decision. If production is pushed toward high-end AI memory, that's less output available for mainstream phones and laptops. So the shortage consumers feel can be the result of priority and profit, not a total global shutdown. So why not just produce more memory? Because memory supply isn't a switch. It's an industrial ramp. You can invest, but you still have to make it work reliably at scale. And there are choke points, not just making chips, but packaging them, testing them, and qualifying them for high performance. That's why just make more is rarely fast. Not because the industry is asleep, because the system has inertia. Phones are where this becomes visible first. Here's a simple question. What happens when a major cost component jumps in a product that competes on price? When memory costs rise, phone makers face three options: raise prices, cut specs, or mix both, quietly. Now the data point. IDC expects global smartphone shipments to fall 0.9% in 2026, while average selling price rises to $465, pushing total market value to $578.9 billion. That's cost pressure, not as a headline, as a price tag or a spec sheet. PCs get hit by a different combination of pressures. First, Windows 10 support ended on October 14, 2025. That pulls upgrades forward, especially for organizations that don't want to run unsupported systems. Second, AI PC marketing pushes baseline expectations upward. More memory becomes the default expectation, not a premium upgrade. Memory is cyclical. It swings from oversupply to shortage, then back again. But this cycle has a twist. The incremental buyer isn't only consumers, it's data centers. And data centers buy at a different scale, with different priorities. So the question isn't, will prices drop next quarter? It's whether memory stays strategically tight across multiple product cycles. Once that happens, planning changes. Phone makers become conservative, PC makers optimize, and everyone watches upstream signals because nobody wants to ship a product that suddenly becomes unprofitable. AI is often described as a race for compute, but what it's really doing is reshaping the supply chain underneath everything else. Because compute is only useful if you can feed it. In the next few years, the most important spec on a phone or a laptop might not be the processor. It might be memory, because memory is where modern computing actually lives. And when that feed line tightens, every device downstream faces the same choice: pay more or do less.